Hello, ladies and gentlemen, Root Beer here, and welcome back to more of the 2008 Euclid contest. We're going to be looking at question number 4 in this video, both A and B parts. Part A here, we just have a light bulb question, so we just need the final answer. A flagpole, FP, is 20 meters tall. From the point A on the flat ground, the angle of elevation to the top of the flagpole is 40 degrees. If B is halfway from A to F, which they have marked here, what is the measure of FBP, so this angle right here, to the nearest degree? Now they're saying the nearest degree, I'm immediately reaching for my calculator. I'm expecting to approximate something. Okay. So, one thing they tend not to point out is the flagpole is sticking straight up out of the ground, and so we have a right angle here at F. And with right angles and angles and some sides, we can use trigonometry to figure out things like AF, and then from there BF, and then use trigonometry to get this angle here. So that's the plan of attack, and we'll just go over to our notepad, draw the picture a little bit. Top of the flagpole, F, A, and then B is somewhere in the middle. Okay, I'll deal with the BP angle in just a moment, but we've got 20 here, and we've got 40 degrees here. Now, you need to sort of remember how trigonometry works, but if I have an angle theta, then, and I'm in a right angle triangle, I've got the hypotenuse, I have the side that's opposite the angle, and I have the side that isn't the hypotenuse, but is adjacent to this angle. And we have a lot of nice relationships. Sine, cosine, tangent. You can even get into some of the other ones, you know, cosecant and things like that. But what do we want? Well, I want to figure out AF. That's currently my plan. So AF is the adjacent side. What do I know? I know 20, the opposite side, and I know the angle theta. So what relates theta, the opposite side, and the adjacent side? Well, there's a nice little sort of mnemonic, or maybe it's sort of an acronym because it is pronounced like a word, like scuba is, not like IRS or something, which is an initialism. But we've got Sohcahtoa, which is a fun little phrase. You know, what do you do if your toe's on fire? You Sohcahtoa. But this tells me really quickly that sine of the angle is opposite over hypotenuse, and so on. And the one that we want is the one that deals with the opposite and the adjacent. So tangent of theta, which in this case is 40, is going to be the opposite side, 20, over the adjacent side, AF. Now, if I want to, I can rearrange this and figure out, well, AF is going to be 20 over tan 40. Great. Now I know BF is 1/2 of AF. So just, divide by 2 on the top. We get 10 over tan 40. Okay. Now, you could have gotten your calculator out and simplified at this stage. I recommend you don't start, getting decimal expansions and using those until you're at the very end of the question, because you don't want to. No one's going to use all. I say no one. I've seen papers where somebody has gotten their calculator out and used all 10 decimal places or however many places their calculator had and just kept that every single step of their calculation. It's annoying, and so most people don't do it, and so you tend to round things off. The only problem is you don't know early on what calculations you're going to make later, and a rounding error to, a hundredths digit might turn out to be a serious problem later on, in that you're off by, somehow you do some calculations and you're off by a whole tenth on your answer. Okay, and that's going to be a bit of a problem. It's not so much of a problem on something like a Cayley or a Fermat because you only have 5 answers, but this is the Euclid. Yeah, we just need our final answer, but we don't have options. We've got to be correct to, I think they said, the nearest tenth for this one. Okay, so we keep our expressions as exact as possible as we go. So now that I know BF, let's add in our hypotenuse. We want this angle here. I'm going to call him theta again. So theta, and what do we know? Well, we know 20, the opposite, and we know the adjacent here. It would be 10 over tan 40. So I know that tan theta, this theta here, that I want to find out is going to be opposite over adjacent. And we can simplify this a little bit to 2 times tan 40 degrees. Well, I want just theta on its own, so I can use, and some calculators will use tan inverse, some of them will say arctan, but we need to undo the tan calculation. Okay, so here's our final expression. This is the answer that we want. We just make sure our calculator is in degrees, and whatever you do, do not, and I see a lot of students do this, think, oh, tan and tan can just quickly cancel each other out. It's 2 times 40, so it's 80. Or even worse, they might just say, well, it's 240 degrees. Tan inverse and tan, they do not cancel out as easily as some people tend to think. So you got to go through the whole calculation. So 40 on my calculator, then I do tan of that. And then 2 times the tan 40. And then I add tan inverse, which usually involves a second function button. And I'm getting 59.2102, blah, blah, blah. But we only need 59 point, the hundreds digit is 1, so we'll round down to 0.2 degrees. And they did say to the nearest, to the nearest degree. Okay. So we just need 59. And that's going to be our final answer. So that finishes up 4A. I've shown my work in case, I'm wrong and I hit a calculator button incorrectly. I've shown my work so I can at least get part marks, but I'm fairly confident we did everything right. Okay, 4B. In the diagram, AB is 21, BC is 16. We know ABC is 60 degrees. We've got 30 degrees over here and a 45 degrees. Determine the length of CD to the nearest tenth. So again, getting out my calculator, I already have it, but I've got it nearby because I suspect I'll need to use it. Okay, now, a little bit of a hint here. In part A, we needed to use trigonometry. I would suspect in part B, we need to use trigonometry. But maybe we should take a moment and say, well, how am I going to get CD? Okay, how could I possibly get CD? Well, if I were going to use trigonometry, I need to know other parts of triangles that CD is in. So CDA comes to mind. And with the 45 and the 30, I can fairly quickly figure out this angle here. And so I could use something like the sine law, if only I knew one of the other sides. Could I figure out either of the other sides? Would it be too much trouble? Well, look at CA. It's part of a triangle as well, and I know 2 of the sides there, and a common angle in between them. That's not going to be sine law, that'll be cosine law. So we're going to do a cosine law to figure out AC, and then we're going to do a sine law to figure out CD, and we'll be all set. Okay, so let's put our plan into action. And something you can do, I'm not going to because I know I'm going to finish, but something you can do if you think, I'm going to run out of time or something like that, you can write down your plan of attack of, first I'm going to figure out AC by the cosine law, then I'm going to figure out CD using the sine law, using this angle and this angle. If you find you might be running out of time or you think the calculations are going to be messy, just telling someone what you're going to do ahead of time provides great clarity, and depending on what you say, could even be worth a mark. I have seen in the past marks being given out for they mentioned they were going to use the Pythagorean theorem. Did they mention Pythagorean theorem at all, or did you see it being used? 1 mark regardless of how it was actually used. Or, in this case, it could be 1 mark because they mentioned the cosine law, 1 mark because they mentioned the sine law. We don't quite know the marking schemes for these things. Okay, so we try and provide enough information, enough justification to get full marks. Alright, so we got 16 here, 21 here, 60 degrees here. 30 degrees here, and 45 degrees here. Okay, so I will say something like, let's find AC by the cosine law. So that tells me AC squared is AB squared plus BC squared minus 2AB BC cos, in this case the angle here is B. So that'll be 21 squared plus 16 squared minus 2 times 21 times 16 times cos of 60 degrees, which might be something that you have memorized as 1/2. If not, that's okay. Okay, it's a useful thing to know, but if you got your calculator handy, by all means, just grab it and do cosine 60, and you're all set, 0.5. Okay, so if we need to, you can grab your calculator and expand this out. The 2 and the 1/2 will cancel out, and so I'm left with 16 times 21, which I don't want to do off the top of my head. It's 336. Alright, so 441 plus 256 minus 336. It's going to be 361, which I recognize as 19 squared. But of course, if you don't, just press the square root button and you'll be all set. So I get AC is 19. I'm going to add that into my picture. I'm going to add it with a different color. Okay. So now that we've got that, now angle D plus angle A plus angle C is got to be equal to 180 degrees. So the angle up here at D is 180 degrees minus 30 degrees minus 45 degrees. 30 and 45 add up to 75, so this is going to be 105 degrees. Even though my picture makes it look like an acute angle, it is not. Okay. So, 105 degrees, fantastic. I'm going to add that in to my picture. Now the thing I want CD. Well, let's find CD by the sine law. And we're going to have to do it on the next page, but basically it's 19 divided by sine of 105 is the same as CD divided by sine of, we've got a 30 here. Okay, so AC over sine angle D is the same as CD over sine of angle at A. Just going to quickly rearrange that. Sine of 30 degrees, I'll bring the sine of A onto the one side, times 19 divided by sine of 105 degrees should be CD. So now it's up to me just to calculate this out. CD is, and now sine of 30, you might be familiar with as well. It's one of those nice special angles. It's also a half. So we're going to get 19 times a half divided by sine of 105. And I'll get 9.83512 da 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 da. So I might say something like, to the nearest 10th, CD is 9.8. And there we go. So the 3 here tells me I need to round down. And it was the nearest 10th, right? Yes, it was. Okay. And that about does it. I've explained exactly what I'm doing. Cosine law, finding an angle, sine law. I've stated those laws, I would say, pretty clearly. If you are particularly worried, you could state the general form of the cosine law and the general form of the sine law in its entirety. I only use the one pair of ratios for the sine law, where it's actually 3 ratios. But Yeah, that about does it. That wraps up question number 4. I think we did it fantastically. I will see you guys for question number 5 in the next video. Take care.